This lesson is about a little law in science called the law of conservation of energy. And we know a little bit about energy already. We know that energy can be transferred. We know that energy comes in many different types. And now we're going to learn about this law of conservation. What the law tells us is that energy cannot be created or destroyed. So we can't just create, you can't have energy come out of nowhere. It has to come from something that has energy. You can't just have your body create its own energy. You have to eat food and take the energy from the food in order to have energy in your body. You can't just create energy. You also can't destroy energy. Energy just gets transferred or transformed from one type of energy to another type, and it just is continually moving throughout our universe, going from one type to another and from one object to another. Here are some examples of some different energy conversions. And an energy conversion is when you change energy from one type to another. So if we look at this picture up here on the top left, what type of energy is being shown in that picture? Hopefully you said light. And that when that light goes into the carrot changes that light energy to chemical energy. Okay? Another example is stove at home. Starts out the energy as electrical energy and changes it into heat or thermal energy. When you eat an ice cream cone, that ice cream cone has chemical energy, and you change that chemical energy into the energy of motion, which is mechanical energy. When you go to the gas pump at the gas station, your gas pump is the gasoline has chemical energy, and your car converts that chemical energy into mechanical energy so it can move. So again, anytime that you have energy changing from one type to another, we call that an energy conversion. And this is only done using a converter device. So in this case, your converter was the carrot. Here your converter device, the device that changed it from electrical to thermal, was the stove. In this case, the object that changed it from chemical to mechanical was your body. And here the car is our converter device. It changes it from chemical to mechanical. Okay? When you're changing energy from one type to another, a lot of times some of that useful energy gets lost. It doesn't disappear, it's just given off to the environment in different ways. And so we can talk about how efficient a conversion is. A really efficient conversion is going to use as much of that energy as it can. And an inefficient conversion is going to lose or give off some of that energy that we're trying to use. So inefficient is not good. Cars actually turn out to be pretty inefficient converters. For example, if you put 100 gallons of gasoline in your car, which would be a very big gas tank, but some vehicles have gas tanks this big, your car's only going to use about 25 of those gallons. Pretty sad, huh? Because they're so expensive. We would say then that your car is 25% efficient, meaning it's really only using 25% of the gasoline or the energy that you're putting into it. The other 75% gets lost. Some of it gets lost as heat that your engine is giving off. Some of it gets lost in running other things, like running the fans to keep your engine from overheating, running electrical in your car, that kind of a thing. Here's some of the places that those other 75% goes. About 33 of the gallons will be lost as heat. So, when you run your car, your engine gets really warm. Well, that heat that's being given off is energy. That's thermal energy that's not being used. 29 gallons is going to be used to cool the engine so it doesn't overheat. 6 gallons gets pumped, is used to pump air through your engine, and 7 gets lost to friction. So really only 25 gallons of that 100 gallons is being used to move your car. So when we're trying to figure out efficiency, there's a couple of ideas. Our energy input, which in our car example was all the gasoline that we put in there that we wanted to use to get us from one place to another, okay? The energy we put in. Then you have your energy conversion device, the device that's going to change the energy from one type to another. In our example, this would be the car. And then what you're going to have is the useful energy output. So how much of that energy that we put in was actually useful? And in our example, there was only 25% of it that was actually useful. Now, how we calculate this useful energy output or this efficiency is using this equation here. So how much of the energy did we actually use compared to how much did we try to use? So we wanted to use 100 gallons. Only 25 of those gallons were actually used to move the car, which means it was 25% efficient. Okay. Another example of this. You put 100 gallons of gas in your car and 30 of those gallons are used to actually move the car. We're going to calculate the conversion efficiency for that vehicle. We have to use that equation. So remember, the equation is useful energy output over energy input. And in this case, the amount of useful gallons says 30 of those gallons were used to actually move the car. So those were our useful gallons. How much energy did we put in there total? That was 100 gallons. So you do 30 gallons over 100 gallons. Put that into your calculator. You're going to get the number 0.3. Now, when we give efficiencies, we want them to be in a percentage. So, of course, always when you change a decimal to a percentage, you just multiply by 100%. So 0.3 times 100. And you can do that in your calculator as well. And what you'll end up with is 30%. So this car is actually 30% efficient, which is pretty typical of a car. Okay. Now that you've worked through an example or two, you have some problems on your sheet in your notebook to work through on that last page of what you taped in. So work through those questions. If you get stuck or you need any help, please let us know.